Greetings, math fans. All right, so this is day 4 of probability, and today's lesson is basically about Venn diagrams and tree diagrams. Now, it's all based on probability, so you're going to have to put things together into, for the first part here, into a Venn diagram, and then you'll be able to calculate probabilities based on that, and then for the second part, it'll be tree diagrams, okay? All right, so let's get started here. All right, so in example 1, the probability that you will get an A on this test is 0.23. The probability that you get an A plus, really, on this test and the final is 0.12, and the probability that you get an A plus on at least one of these assessments is 0.41. So you have two different possibilities. You have getting an A plus on the test, and you have getting an A plus on the final. So we're going to draw two circles, which is what our Venn diagram is, okay? So this center part is like the combination of both that are occurring, and then you have each one. So we'll label it test and final exam. Okay, final. All right. And we'll try to use some colors here too, because it makes it all so more exciting if you do that. Okay. So the first thing is, this is the probability that you get an A plus on this test is 0.23. Now what I want you to understand is, sometimes people say, well, is it just on this test? And it's not just, it's just, basically it's a blanket statement saying the probability that you get an A plus on the test is 0.23. So if I have to color this in, and you might be saying, well, Mr. Krebs, why are you shading in that middle part? Well, that's part of the probability of getting a test. You still can get an A plus in the final, but the probability of getting an A plus on the test is 0.23. So I'm going to put a little red dot here because that's what that represents, okay? And let's change the color here again. Let's go with blue. Okay, the probability that you get an A plus on this test and the final. Now we have the intersection. So that's this guy here. I guess it's purpley. I'm not sure what that is. That's kind of a weird color. That was kind of weird. Okay, is 0.12. Okay, so that's like the intersection of the two. And then the last thing, it says the probability that you get an A plus on at least one of these assessments is 0.41, which means the test or the final or both. So this, well, actually use a different color here. Let's use, okay, let's use green here. So this is going to be, this guy here is going to be 0.41. Okay? All right, cool. So really, before you even start this out, it's good to figure out the rest of this. And what I mean by the rest of this is, if I want to say, what is the probability of just getting an A plus in the test? Okay? So let's do that. If I want to do, let me change the color again here. I've kind of figured out what I need to do to change the color. So let's make this, I don't know, let's go with bright pink. Okay. All right. So if I want to just get an A plus on the test, that's this guy right there. Okay. So the bright pink, or I guess it's bright pink, okay, it's going to basically be the whole thing, which is 0.23, minus 0.12, which is that overlap, which is that purple. So minus 0.12, and that's going to give us 0.11. Okay, so this is the test only. So just the test. Okay, so let's pick another color here. And we'll go with, I don't know, sky blue. Okay. And then, so if I want to do just the final only, it's going to be this guy here. This is going to be just the final only. Okay, by coming up with these different probabilities is going to help us solve the whole thing. All right. Anyway, that whole thing is going to be, do you agree? It's 0.41, which is the whole thing minus the whole test that I did. Okay, minus the 0.23. Okay, which was that the whole test thing. If I take that away, that's just going to be the final exam. Okay, and we get 0.18. And again, this is going to be the final only. Okay? All right, cool. So once you have this on there, now the 3 questions are actually going to be pretty easy. So let's go and take a look at the first question here. It says find the probability of not getting an A plus on either this test or the final. So by not getting an A plus, do you agree that if this probability right here was the probability of getting an A plus on, and it even says it here, the probability of getting an A plus on at least one of them, so the probability of not getting it on any of them is 1 minus 0.41, which is 0.59. Okay? So remember, if I told you the probability of it raining is 0.6, the probability of it not raining is 1 minus 0.6, which is 0.4. So that's what this is saying here. Okay? All right, the next question, then we'll cursor back up again so we can see everything. The probability of getting an A plus on the final, but not on this test. Well, we already figured it out. Here it is, man. We already calculated that one. So probability of getting a final just on the final. That's what it's saying. Probability of getting an A plus on the final is just 0.18. Okay, and again, that's what we calculated right there. Okay, and then the last question is find the probability of getting A plus on only one of the 2 assessments. So what this means, only one means not both. Okay? So if you think about it, that means the probability of getting an A plus on the test only, plus the probability of getting an A plus on the final exam only, which is what I calculated up here. That's the 0.1 plus 0.18. So 0.11 plus 0.18, which is 0.29, and that's your answer. Okay? So it's really, these are easy questions if you've got that Venn diagram filled out correctly. So again, this is the test only, and this is the final only. Okay? Very easy if you have that Venn diagram. Okay? All right, so let's do one more. And if you want to pause the video and you want to try it first and then watch me do it, that's great. Otherwise, I will just do it right now. Okay. So again, I'm going to be drawing another Venn diagram here. All right, so let me change my color back to black for our main diagram here. Okay, so we're going to draw 2 circles. Okay, so the probability we'll get a snow day, which actually is really funny because when I'm making this video right now, it is January 26th, and we just had a snow day today. Though because it's COVID times, that's why I'm making this video in 2021, we actually had a remote day, not a snow day. It's very kind of funny that I'm actually making this video right now. Okay, anyway, so the probability that we get a snow day in January is 0.31. So actually, let's label this because we have snow days in January and February. So this is January, and this is February, snow days. Okay, so let's change our colors now. Okay, we're going to go with I'll go with green. Okay, so the probability we'll get a snow day in January. It doesn't say it can't happen in February. So when I think sometimes people just want to shade just the January part and not the February, but truly that's not what I'm saying. So the probability of having a snow day in January is 0.31. Okay, so that is the green 0.31. Okay, the probability that you'll get a snow day in January and February, so that's my overlap. So let's change our colors here now to, let's do orange, I guess. This is my overlap, so this is going to be 0.16. Okay, and then it says the probability that you'll get a snow day in at least one of the 2 months. So once again, that is going to be, we'll make it purple. That's this guy right here. Okay, that's going to be 0.38. Okay, so remember the two other things I need to fill in, guys? Is I need to say, hey, what's the probability of just getting a snow day in January, and what's the probability of just getting a snow day in February? Okay, so let's do that. Again, I'm going to change the color here. We'll go with a dark blue. Okay, so if I said just January, this is just January. Okay, and just January, which we'll make it a blue dot here. That's going to be the whole thing, the whole circle, which we figured out was 0.31, minus the overlap. So that's going to give us 0.15. Okay, so that is January only. Okay, now we need to do February only. Okay, so let's change our color one more time here. Let's go with bright green. How's that one? Okay. Okay, and so anyway, here's February only. Okay, February only, so that's that one. And if you think about it, that's going to be the 0.38 minus the whole January, that big circle, which was 0.31. So that's going to be 0.07. And this is February only. Okay? So that's going to be pretty nice here now. Let's do our problems. We pretty much have all the information to do everything. So it says find the probability of not getting a snow day in either January or February. Well, do you guys agree, though, again, that 0.38 is getting a snow day in January, February, or both, in at least one of those days. So that means it's going to be 1 minus 0.38, which is 0.62. Okay. The next one says find the probability of getting a snow day in February, but not in January. Oh, we already figured that out. There it is, February. So it's 0.07. Perfect. Okay, and then the last one, it says find the probability of getting a snow day in only one of the 2 months. Well, that means in only January or only February, and we have them both there. And remember, or means add. So January plus February. So 0.15 plus 0.07, which gives us 0.22. So again, this is January only, and this is February only. And there we go. That's really how you set up these probability Venn diagrams. Very easy to do that, okay? And again, you will see this on the quiz. You'll see a problem just like this on the quiz. You'll see a problem just like this on the test, and you'll see a problem just like this in the final exam. So make sure you know what you're doing with this. Okay, math fans? Okay. I get so excited when I do videos. It's so exciting. Okay. All right, so the next part, that was a Venn diagram. The next part are tree diagrams. So I want to give you guys one problem where I actually give you the tree diagram, and then I want to give you the next problem where you actually have to make your own tree diagram. Okay, because it's important to know how to use one, and it's important to know how to make one. Okay, so if you look at this diagram, it says the probability of passing a test is 0.08. The probability of failing the test is 0.2. Okay, understand these probabilities have to add up to 1. Because you've either passed it or you fail it. There's no in between. Okay? And so once you go past, let's say you pass the test, then you take the final exam. Okay? And it's the same probability off of the test, which let me highlight this and then I can erase it. Okay? After you take the test, which is 0.8, then it says, well, based on passing the test, what's the probability of passing the final? Well, it's 0.7. What's the probability of failing the final? It's 0.3. It's different than if you actually fail the test first. Okay, you can see the probabilities are different. Now, if you fail the test, the probability of passing the final is 0.4, and the probability of passing the final is 0.4, and the probability of failing the final is 0.6, which kind of makes sense if you think about it, right? If you pass the test, you have a better chance of passing the final. If you fail the test, you probably have a worse chance of passing the final. You're probably going to fail the final. Okay? So let's do this one now. Let me erase that part there. Okay. And we'll go with a nice purple color. I like it when I get to choose my colors. Okay, cool. So remember our probabilities. You have ands and ors. And means you multiply, or means you add. Pretty important concept here, okay? So if I said, for the first question, what is the probability of passing this test and failing the final? So both have to be true. So that's why I have this nice little and here. So let's go. If you pass the test, there's pass the test. So it's 0.8, and the probability of, or then and failing the final. So it is. There's the probability of failing the final. So both times 0.3. So the answer to that one is 0.24. Okay? It's pretty easy. Get rid of the stuff on here, and then you have a fresh picture. Okay. So now it says, if you pass this test, what is the probability of passing the final? So I want you guys to see the wording in two different ways. We've already done conditional probability. Conditional means given. That's a key word here, given. Okay? So something already happened. That's what the given means. It's something has already happened, which goes really well with the tree diagram, which means if something has already happened, then you follow a certain branch of that tree. Okay? So reworded, again, let me read the first statement again. If you pass the test, what's the probability of passing the final? So it's saying that you passed the test. So if I reword it, it'll say, hey, what's the probability of, let me highlight this, what is the probability of passing the final given that you passed the test? Because it's telling you passed the test, so that you're given. Okay? So what I want you guys to do is, there's two ways to do this problem, this type of problem. So think about it. If you pass the test, do you agree you're on this branch? Okay? So if I pass the test, I'm there. What's the probability of passing the final? Well, the answer is just 0.07. What? That's easy. Okay? Yeah, it is easy. I already told you passed the test, so I can ignore the 0.8 because I already passed the test. Now I'm right here. I'm in this spot here. Now I say, oh, well, what's the probability of passing the final? Oh, it's 0.7. Or I put 0.07. It's 0.70. Sorry. It's 0.7. Okay? All right, cool. Let's do it actually a little mathematically. Okay? You guys know that the probability of passing, it says, what is the probability of passing the final? So pass the final given that you passed the test. So if you remember this mathematically, this is the probability of passing the final and pass the test divided by the probability, and remember this one always goes here, probability of passing the test. Okay? So let's do it mathematically and see if we get the same thing. All right. So the probability of passing the final and passing the test. So let's go back up here. Probability of passing the final and the test. So that's going to be passing the final and passing the test. That's going to be 0.7 times 0.8. Okay? 0.7 times well, let's do a 0.8 times 0.7. Just keep it in order there. 0.8 times 0.7. Okay? What's the probability of passing the test? Well, do you guys agree probability of passing the test isn't at 0.8? So I drew a huge line there, but these cancel out and you just get 0.7, which is exactly what we did in the beginning. So this one's actually a really pretty easy one. Okay? If you did it mathematically, that's great. You can do this little bit of work here and you see that 0.8s cancel out. Okay? But if you just look at it, if you pass the test, you can just look at it and you say, oh wait, I passed the test, so I'm already beyond this first part of the tree. I'm actually on the second part of the tree. Okay? All right, so let me erase that. And the second part is just a little more challenging. Okay. So the next part here, it says, let me get my pen again. Okay, if you pass the final, what's the probability of passing the test? Okay, so this is the opposite of the one above it. The other one said if you pass the test, what's the probability of passing the final? Now it says, hey, you passed the final, what's the probability of passing the test? So do you guys agree this is given? If you pass the final, what's the probability of passing the test? So there we go. What's the probability of passing the test? Given that you pass the final. Now you can't just do this one by looking at the chart, okay? And the reason you can't do that is because it's saying if you, it says if you pass the final. Well, passing the final is here and here. So it's not like I can say it's the first part of this. Okay, so actually I have to do it mathematically. I have to. So what you're going to do is you're going to say what's the probability, so we're going to use that second word, the reworded one. What's the probability of passing the test? So pass the test given that you passed the final. Okay, so that's going to be probability of pass the test and pass the final divided by the probability of passing the final. Okay? All right, so let's go back up. The probability of passing the test and passing the final. That's going to be, let me again clear a couple things out of here. Okay, so the probability of passing the test and passing the final, same thing, 0.7 times 0.8. So let me cursor down here. So it's 0.8 times 0.7. Okay? All right, that's good. This one's a little more complicated. Not bad. What is the probability of passing the final? Well, again, let me erase this. The probability of passing the final is, you're either going to, here, let me circle passing the finals. So you're either going to pass the test and pass the final, or you're going to fail the test and pass the final. There's actually two parts to it. So it's either this or this. Or, very interesting. Okay, or means add. So, and this means, and means multiply. So it's going to be pass the test and pass the final, or fail the test and pass the final. Okay, there we go. Let's put it in there. So it's going to be 0.8 times 0.7. That's pass the test and pass the final, or fail the test and pass the final. Okay? Got to know that setup. You think you might see this again? I would go with yes. You will see this kind of problem again on the quiz, on the test, and on the final exam. Gee, Mr. Kerfus, I better study this because this is on the test and the quiz and the final. Yes, you should. Okay. Remember, guys, the key to finishing this up is make sure you put parentheses around the bottom. You can type in 0.8 times 0.7 divided by parentheses 0.8 times 0.7 plus 0.2, 0.4. Because if you don't put in parentheses, you're not going to get the right answer. It's going to divide 0.87 divided by 0.87, and then it's just going to add it's not going to divide that 0.2 times 0.4. Okay? So try it on your calculator. So try it. Anyway, it's going to give you 0.88 as a final answer. Okay? So just even looking logically at this, do you guys agree these probabilities are actually pretty high? Because think about it. If you pass the final, what's the probability of passing the test? Well, it's probably pretty good, right? If you pass one, you're probably going to pass the other. Same thing with part B. It says if you pass the test, what's the probability of passing the final? Well, sure, if you pass the test, you're probably going to pass the final. So it's kind of a high probability too. Okay? All right. The next question, it says, what is the probability of failing the final? So let's go back up here. Again, let me erase some of this stuff here. Okay. Okay, so it says, what is the probability of failing the final exam? So think about it. The probability of failing the final is, well, it's here and it's here. Please don't just add those together. Okay? It's actually, you got to pass the test. It's two scenarios. You either pass the test and fail the final, or you fail the test and fail the final. Okay? One of those two. And we've kind of, this is kind of what we did down here with this. It was kind of two scenarios. If I want to, what's probably passing the final? It's passing the test and passing the final, or failing the test and passing the final. One of the two scenarios. So anyway, the probability of failing the final is going to be, so let me just write a couple words here, okay? You're going to fail the final and fail the test, or fail the final and pass the test. Okay, it's two scenarios. Okay, so it's going to be, if I kind of keep that in the same order, fail the final is 0.6, and fail the test. So 0.6 times 0.2 plus fail the final and pass the test. So fail the final is going to be 0.3. Again, keeping in the same order. And then pass the test is 0.8. So that gives us 0.36. Okay, which is pretty low. What's the probability of failing the final? That's pretty low. Yeah, all right, that's cool. Okay, E, what's the probability of passing this test? Guys, that's like really easy. Look back at the whole diagram here. What's the probability of passing the test? Okay, it is right here. Probability of passing the test is 0.8. And you might say, well, Mr. Griffiths, shouldn't you do both scenarios? And I would say, okay, you can. You can do that scenario, so those two multiplied plus those two multiplied. But think about it. That adds up to 0.1, or to 1.0. So 0.8 times 1.0 is 0.8. So you can just pull that right off of there. So that's going to be 0.8. Okay? So that's just look. Look at tree. All right, F. What is the probability of passing both the test and the final, or failing both? Well, you got a lot of stuff here. So what's the probability of passing both the test and the final? So let's look at the tree diagram. Probability of passing the test and the final. Let me get rid of that again. Okay, so the probability of passing both the test and the final is 0.8 times 0.7. So let's do that. It's 0.8 times 0.7, or failing both. Let's go back up to it. How do you fail both? Well, you fail the test and you fail the final. So 0.2 times 0.6. Okay, and you multiply those out together and add them together, and you get 0.68. Okay, so remember your ands and ors. Ands mean multiply, or means add. Okay, so my last question is, what do all the probabilities add up to? So think logically. When I say all the probabilities add up to, if I added, and again, I keep doing this here, but I want to erase that. Okay. So I'll use the highlighter here. Actually, I didn't want to erase it first. Okay, sorry. Okay, so if I want to add all these together, what do all the probabilities add up to? So if I add that one up, I guess I can, that one, I'm getting fancy here. This one, ooh, I like the colors, nice. And this one. Okay, if I add all those probabilities, so 0.8 times 7, 0.7, 0.8 times 0.3, 0.2 times 0.4, and 0.2 times 0.6, what do they all add up to? Anybody, okay? They all add up to 1.0, okay? Because all the cases are here, every scenario. You're going to pass the test or fail the final, pass the test or fail the final, or fail the test and pass the final, fail the test and fail the final. One of those scenarios. That's why that adds up to 1.0. Okay? Cool. All right, so the last part here, it's a little long, but spending a little bit of time on this, so it's okay. Okay, so last thing here is you have to make your own tree. Okay, so let's do that. Example 2. Okay, 73% of all students like sweet treats. Of the students that like sweet treats, 84% like salty treats as well. Of the students that don't like sweet treats, 61% like salty treats. Create a probability tree and answer the following questions. Okay, so this is what the diagram is going to look like. You can draw it on the branch. I personally like to draw it this way. So you can do it any way you want, but I like to put a box here. And then I'm going to do another branch off of those. Okay? All right. Not a very good tree. I would not be good at designing trees. Okay, so we're going to say this is like sweet, and this is don't like sweet treats. Okay? And then this is like salty, and this is doesn't like salty. And this is again like salty, doesn't like salty. Okay? It's really pretty easy to set this up. So now it says 73% of all students like sweet treats. So this is 0.73. And that means you're going to do 1 minus that because you either like sweet treats or you don't. So 1 minus 0.73 is going to be 0.27. Okay? And then it says of the students that like sweet treats, so we're on the top one, 84% like salty treats. So 84% like salty, that means 1 minus that, so it's 0.16 don't like salty. Okay, of the students that don't like sweet treats, I'm in the bottom one, 61% like salty treats. And that means 1 minus that, which is 0.39. Don't like salty treats. Okay, so now we're going to answer all the same questions or similar questions using this. Really pretty easy. So I'll go through this a little bit faster now, okay? So if a student likes sweet treats, what's the probability of liking salty treats too? Again, this is a conditional probability, guys. I'm telling you a student likes sweet treats. That's my given. Okay? So remember, one of them you could just look at this at the tree, and the other one you actually had to do a calculation. Look at what they're asking. If a student likes sweet treats, do you agree we're already past this? So if a student likes sweet treats, what's the probability that they like salty treats? Well, look at the chart. The probability of liking salty treats is 0.84, and that's the answer. Again, if you wanted to use probability, I could do this really quickly. Probability of liking salty, so like salty, given that you like sweet. That's the probability of like salty and like sweet divided by the probability of like sweet. Okay? So looking up on top here, like salty and like sweet, that's going to be 0.73 times 0.84. Probability of liking sweet, well, that's just 0.73. And you can see the 0.73s cancel out, and you just have 0.84 as your final answer. Okay? So definitely this is one you can just look at it. Now, if you notice, the next one's going to be different. If the student does not like salty treats, what's the probability of liking sweet treats? Okay? So if I said the student doesn't like salty treats, that's going to be not liking salty treats. Let me cursor down here. Not like salty treats and not like salty treats. It's actually two scenarios. So either you like sweet and you don't like salty, or you don't like sweet and you don't like salty. So that's why it's a little bit more difficult. So you can't just look at the chart here. So that is going to be the probability of probability of liking sweet. So like sweet, given that you don't like salty. Okay, so that's probability of like sweet and don't like salty. A lot of words. Okay, divided by don't like salty. And what does that mean? That means it's two scenarios, right? Well, here, let me write this first. So probability of don't like salty. Okay, so the top one's easy. Like sweet and don't like salty. So let's look at the chart here. Like sweet and don't like salty. So you guys see it's 0.73 times 0.16. Okay, so 0.73 times 0.16 divided by the probability of don't liking salty is, once again, it's don't like salty is that and that one. It's that or that. So 0.73 times 0.16. So 0.73 times 0.16 plus 0.27 times 0.39. Okay? And again, make sure you put parentheses around that bottom, and you get 0.53. That's your answer. Okay? Cool. C, what is the probability of a student liking both salty and sweet or not liking either? Okay, well, that's probability of like salty and like sweet plus not liking either. So probability of not like salty and not like sweet. Sorry, a lot of words there. Okay, but it's basically just pulling probabilities off now. So probability of liking salty and sweet, if I go up to this, like salty and sweet is 0.73 times 0.84. So 0.73 times 0.84. And the probability of liking neither, let's go back up, is 0.27 and 0.39. 0.27 and 0.39. Okay, and that gives you 0.72. Cool? Okay, D, what is the probability of a student liking sweet treats? Let's go back up to that one. Do you guys agree that's a really easy one? What's the probability of somebody liking sweet treats? 0.73. All right, that's easy. 0.73. I'll put in here, just look at the tree. Okay. What's the probability of a student liking salty treats? That's not as easy, but liking salty treats is, again, you're either going to be this scenario or this scenario. So you got to pick the liking treats. So you're either going to like sweets and like salty, or you're not going to like sweets and you're going to like salty. Okay, so it's one or the other. So let's write that out here. It's the probability of like salty and like sweet plus the probability of like salty and not like sweet. Okay? So again, you're going to pull that off of there, and you're going to get 0.73 times 0.84, like salty and sweet, or which is 0.27, which is don't like sweets, but still like salty, 0.61. Okay, and that gives us 0.78. So if you notice, it's a little more complicated when I ask you something about the second part of the tree, the branches, the like salty, the don't like salty. It's more complicated because you have to figure out a couple of different probabilities. If I ask you for the first part of the tree, it's easy because you either like it or you don't like sweets. So that's kind of already set there for you. Okay. Okay, and the last one here, it says, what is the probability of a student liking both sweet and salty treats? Well, so probability of like sweet and salty. So just remember, it's and. So probability of liking sweet is 0.73, and the probability of liking salty is 0.84. Okay, so you get 0.61. Okay, and again, if you added all those probabilities together, you multiplied the top one, the middle one, the next one, and the next one, you add them all together, you get 1.0. All right? So that was kind of a little bit longer video, like 43-minute video, okay, but it's kind of got a lot of stuff to it, right? And I spent a little time drawing all the pictures and everything. Hopefully you guys are good to go, but I definitely would know how to do a Venn diagram. There are several questions like this on the final exam. And also the tree. The probability trees. There are a few questions like that on the final exam as well. Okay, so make sure you know how to do this for the quiz, for the test, and for the final exam. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.